Okay, in this video, we're going to look at how we can write an equation of a function after a vertical translation. So just let's talk about what does it mean that we're doing this thing called a vertical translation. Well, let's just say we have a graph, right? And on our graph, we have a function. Let's say it's a parabola, right? Let's say this is our original function that's called f of x. If we take that exact function, and all we do is simply slide it up or slide it down, and all of the points just move up or down, not left or right at all, that's called a vertical translation. So let's just say I wanted to take every one of these coordinates and move them down 3. So I'd go down 1, 2, 3, and move that point right down there, and that point would go down 3, and all of these points down 3, we would get something like this green graph. Let's say that's g of x. Okay, so g of x would just be that function moved down 3. That's a vertical translation. So what we're doing in this example, or these problems I should say, is we're taking an original function given to us and trying to find the equation for a new function if it were translated either just upwards or downwards. And I think you're going to find that once you see the trick behind this, it's actually quite simple. Let's look at example 1, and we'll see if we have time for 2. But let's say if I'm given the original function, and I'm going to call it g of x, and it's equal to 4x squared plus 1. So if this function is translated, let's go up 6 units to make a new graph that is called h. Okay. We want to find the expression for h of x. So we want to, what is this new equation going to be? Okay, well, I'm going to explain this in as best detail as I can. Let's look at this original equation very carefully. Now, for this function, every single coordinate has an input and an output. So, the input is the variable x, the output is actually g of x. This is the input. We plug in x values and we get out these outputs called g of x. For example, if I were to let, let's pick something easy. Let's let x equal 0. We would have 0, comma, and if I were to plug in 0 and square it, that's 0, times 4 is still 0. 0 plus 1 would be 1. So if I were to plug in 0 for my function g of x, I would get out 1. Okay, so we have all these coordinates that are of this form, x comma g of x, for this green guy. I want to find a new function where basically I want to move it up 6 units. Well, if I want to move this coordinate up 6 units, think about that for just a second. 0, 1, that point, if I were to just focus on that one point, is right here, right? That's 0, comma 1. I want to move that up 1, 2, 3, 4, 5, 6, right there. Well, think about this new point. This new point is at 0, comma, what is that, 7, right? All I really needed to do to get the new coordinate would have been just to add 6 only to the y value. Well, really, if I want to do that for all coordinates, don't I want to add 6 to the g of x values? So all I have to do, if I want to find this new function h of x, now think h of x also is going to have inputs for x, and the outputs for this new function is h of x. So the inputs are the same, but the outputs for h of x is the same as just g of x, add 6. All we want to do is add 6 to the g of x values. So what I would tell you to do is this: to find your new function for h of x, that's simply going to be the original g of x, but we just want to shift that up, so we're going to add 6 to it. So we take g of x and we add 6. And you might say, well, that still looks confusing or weird. But guys, realize we know what g of x is. G of x is 4x squared plus 1. So instead of writing g of x, I can say, hey, that's really just 4x squared plus 1. And all I have to do to that, so all I have to do to that value for g of x is add 6. And that will give me my new function for h of x. Well, I have parentheses around this, but I'm not distributing anything. All I have to do is add the like terms, and I'm done. My h of x value would be 4x squared, and if I add 1 plus 6, that's positive 7. That's my expression for h of x. And by the way, if I were to plug in 0, and I square it and multiply it by 4, that's 0 plus 7, that's 0, 7. Hey, doesn't that match whoop, 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 right here, the coordinate it was supposed to be? Remember, if we had the original function at 0, 1 and we shifted up 7, we land at 0, 7. Well, here's the proof. We just created a function, at least for that point we've proved it, that when I plug in 0 I get 7. So I feel really confident about this. Let me show you just one more quick one. If I gave you, let's just make one up real quick. If I gave you, let's say f of x, I'm calling f of x 2x squared minus 1, and that is translated downwards 3 units to make, let's call it g of x. Find the expression for g of x. Well, if we just cut to the chase, all right, g of x, if I were going to create g of x is simply going to be f of x take away 3. If we're moving it down 3, we're going to need to subtract 3 from all of those y coordinates or outputs, which is the f of x values. So f of x is really 2x squared minus 1. So instead of writing f of x, I can write 2x squared minus 1 and subtract 3. And so combining like terms would give 2x squared minus 4. So my new function for g of x would just be 2x squared minus 4. All I have to do is subtract 3 from that f of x value. Hopefully this helps you guys. Thanks for watching.